Consider the Prince Sultan Air Base in Saudi Arabia. It is designed to be a vacuum of risk, a desert facility shielded by Patriot missile batteries and the most advanced electronic warfare suites in the American arsenal. Its primary asset is the E-3 Sentry. This $300 million aircraft acts as an orbital eye, using a rotating radar dome to scan 400 kilometers of airspace in every direction, providing the data necessary for total air dominance. But analysts are now modeling a scenario where this entire defense architecture fails. In this projection, a swarm of $20,000 drones and low-cost ballistic missiles penetrates the base's perimeter, successfully destroying an E-3 Sentry on the tarmac. The mere threat of such an attack has already forced tactical shifts. Trillion-dollar aircraft carriers, usually the ultimate projection of power, have been observed pulling back from coastal positions to stay out of the range of cheap, land-based missile batteries. This vulnerability was underscored when an MQ-4 Triton, the U.S. Navy's most advanced long-range surveillance drone, simply vanished from radar during a mission. A $180 million sensor platform was lost to an adversary with almost no traditional air force. The math of modern warfare is shifting. When a single $20,000 drone can neutralize a $300 million aircraft, the side with the most expensive technology is no longer the side that is guaranteed to win. This shift isn't accidental. It relies on a specific playbook that allows sanctioned nations to bypass the need for a traditional military-industrial complex by weaponizing three specific technological advantages. First, an adversary no longer needs to build its own fleet of spy planes. Instead, they can simply lease space on commercial satellites. Iran, for example, utilized the Earth-Eye satellite from a Chinese company to map every inch of U.S. military installations across the Gulf. These commercial sensors offer 0.5-meter resolution. From space, an operator can identify individual parking slots, track fuel tanker movements, and even read the tail numbers off a fighter jet's wing. Guidance was the next hurdle. Historically, the U.S. controlled the GPS network, famously denying access to adversaries during crises to leave their missiles blind. In 1996, they even used this tactic to disrupt Chinese missile tests during the Taiwan Strait crisis. To break this monopoly, nations are moving their guidance systems to the Chinese Baidu network. Because it operates on different frequencies, American jamming equipment cannot easily knock these drones off course. The scale of the shift is massive. Baidu uses 45 satellites compared to the 24 used by GPS. This density allows for a military-grade accuracy of just 10 centimeters, precision that used to be a Western exclusive, now available on a budget. By leveraging commercial satellites for targeting and foreign navigation networks for guidance, a nation can execute precision strikes without owning a single high-tech factory. The final stage of this playbook turns war into a pure contest of economic attrition. Every time a $2 million interceptor missile is fired to stop a $20,000 drone, the defender loses. The goal isn't necessarily to hit the target, it's to force the defender to run out of money and ammunition first. This volume is achieved through reverse engineering. By capturing crashed Western drones, nations have learned to mass-produce cheap, suicide versions that can be deployed in swarms of 30 or 40 at a time. Even a $1 trillion defense budget cannot solve this math problem. If an adversary can produce drones faster and cheaper than you can produce interceptors, your defenses will eventually collapse under the sheer weight of numbers. India now faces a choice. We are still operating on a defense playbook written for the last century, but our own infrastructure is showing dangerous signs of technological dependence. We have felt the sting of this dependence before. During the 1999 cargo war, when Indian troops were fighting in these mountains, the U.S. cut off our GPS access. We couldn't get the exact coordinates of enemy bunkers, a failure that cost Indian lives. India's response was Navik, our own satellite navigation system. But that system is currently in a state of decay. The atomic clocks on several key satellites have failed, and the replacement launches haven't kept pace. For the system to provide accurate military data, it needs at least 7 satellites working in unison. Today, only 3 are operational. Our independent brain is effectively offline when we need it most. This dependence extends to our most advanced hardware. While we have the Rafale, France has refused to share the source code. This means we cannot integrate our own indigenous missiles or modify the radar without Paris's permission. Without the source code for our jets and without a functional navigation constellation, India's air power is not truly sovereign. It is a high-tech machine that can be remotely disabled by a foreign power's decision to stop providing software updates. Despite these warnings, India's defense spending remains focused on massive, high-visibility assets that the new era of warfare has made increasingly vulnerable. We are spending over 50,000 crore rupees on aircraft carriers and main battle tanks. These are massive targets that can be disabled by a drone costing less than a mid-range sedan. Our drone strategy follows the same pattern of buying prestige over volume. We are spending $3.5 billion to buy just 31 MQ-9B drones from America. To put that into perspective, that same $3.5 billion could fund the production of 7,000 low-cost indigenous drones. That is the difference between a small fleet of 30 targets and an unstoppable army of 7,000 attackers. We have the prototypes, like the Nagastra 1. The technology works, but the production orders remain in the hundreds, while our adversaries are preparing for a war involving tens of thousands. The next war will not be won by the nation with the most impressive parade. It will be won by the nation that can mass-produce autonomous swarms and maintain total sovereign control over its satellites and software. India must decide if it wants to keep buying expensive targets or start building an asymmetric future.